alkylation reaction on amine is a very popular question on the quiz and test because we just talked about so many different reactions with it, right? And you don't want to confuse by the reagents, right? Decontamination is like this: ketones and aldehyde with an amine, right? Ketones or aldehyde with an amine makes an imine first, right? That is this nitrogen makes an attack for carbonyl. That electron pairs goes up. That is a first intermediate. We call it tetrahedral intermediate. Proton transfer here to there, right? That's what we expect. Once that happens, these hydroxyl groups can be protonated from the proton from the solvents. Then you got water sitting on it. So what happens is these lone pairs coming in, taking up nitrogen carbon double bonds, kicking the water molecules out. And then this proton goes away. That makes a neutral imine first. That's not amine yet. Imines are produced at the first step. A second step is lithium aluminum hydride. So imines get reduced to the amine. I mean, lithium aluminum hydride is actually a pretty powerful job. You can simply use lithium hydride and do the same thing. So you get an amine. So this is basically just a reductive amination. It's popular. Another way, carboxylic acid, if you're treating with thionyl chloride replaces OH with a chlorine, right? That makes an acid chloride. That acid chloride reacts with amine, that makes an amide. This reaction happens and you get this, you get the alkoxy groups, tetrahedral intermediate. But the thing is, the chlorine is a good living group. That's the what makes the difference is. This comes back making carbonyls and then kicking the chlorines out. So you get the amide. So amide treating with bromine and the sodium hydroxide. This is where you should remember the reagent, right? Amide reacting with the halogen with the sodium hydroxide or potassium hydroxide. That's the Hoffman elimination, the rearrangement reactions. So eventually, this carbonyl goes away as a carbon dioxide. You get this nitrogen connected to the bond directly to the alkyl chain. So you get that. So that's a Hoffman rearrangement. So you really need to know your reagents. That way you can easily figure out what reagents you need to figure out. All right, these reactions. Sodium cyanide is a good nucleophile. We have a halide there. I can use anything there. I can use chlorine. I can even use tosylate. Remember that? The alcohol reacts with the tosyl chloride, then that also makes a good living. The thing is, that makes a reaction, this kicks out. That's an SN2 reaction. You got the inversion of stereochemistry, right? Remember that? Cannot forget old stuff. SN2 reactions happen. That's the first step. Second step, reduction of the lithium aluminum hydride. That reduces this to the methylamine. So that's what it is. Why the first step water there? That's just walk-up step. In the end of the reaction, you gotta get rid of the lithium aluminum hydride, so you add the water. You protonate something is not protonated, or you take the protons away, something that is protonated. So water in the end, that's nothing but just a walk-up step. So you don't need to consider that as a field step. But sometimes people put it like that. Anyway, that's what happens. This reaction here is, if you recognize phthalate imine anion, that benzene, the true carbonyl in ortho position, is called the phthalic acid. Phthalic acid makes a recycled structure with an amine, it's called the phthalate imine. And then there's an anion, so there's a proton, so that's why phthalate imine anion. A lot of different names given. When the nitrogens make a double bond with a carbonyl or one carbonyl, that's an amide. When it's a two carbonyls onion like this, it's called an imine. So, and then this imine is there, so many different names given depending on their structures. So I know that could be confusing, but you probably have to get used to it. Because imine, amide, imine, ana, all those things. You're going to hear a lot about biochemistry, so you cannot do about that. Anyway, so this is a new profile. That new profile makes an attack to this program, picking the halogens out. It's nothing but SN2 reactions. That make a phthalate imine is connected to this carbon chain. So we get the alkylation done. Second step, hydrazine is getting rid of the phthalate imine as a phthalate and the hydrazine amide. So that is comes in, replacing this part, that comes in replacing the other part, so we get the amine prepared. So that's called Gabriel amine synthesis. I want to show you other way to make this happen. If you want to make it happen, you can easily use a sodium azide as well. Sodium azide is as a really good new profile that makes an attack by SN2 reaction, and you get an azide form. But azide can be reduced to amine by liquid hydride. It can be, the hydrogenation can be used too. Hydrogenation can be used an azide to amine, but I don't want to do the hydrogenation here. Can anyone guess why I don't want to do the hydrogenation? Yeah, you recognize this bubble here. If you're using a hydrogen gas with the palladium, that's going to be reduced too. So you got to choose the right reducing agent for the occasion. So lithium hydride, I mean, for that is I put it there for as a part, but in this reaction you cannot do it. Because if you're using this, you reduce that at the same time you reduce that one. It's going to be single one. Then you got to get the partial credit. So you got to choose the right agent. Anyway, so that is exactly the same thing. So Gabriel amine synthesis or reaction with an azide is basically replacing chlorine with a nitrogen, so you get the negative amine. I want to show you the differences between the sodium cyanide and azide on the other thing. Sodium cyanide make a reaction there, same thing as a 2 reaction with a CN there. That can be reduced by the lithium hydride. Then that's going to be the methyl amine. You see these structures not the same as that. Difference is that carbon. This carbon came from the cyanide. Cyanide comes with a carbon. That's going to remain as a part of the product. So when you're using a cyanide as a new profile, make it as SN2 reactions. If you reduce it, you are adding a carbon. I hope that you remember that. Because if we ask this question to see that whether we can analyze the situation properly,